Welcome to this video. I'm Has Physics and today we are going to be going over work, energy, power and efficiency. So first we are going to be looking at energy. The first type of energy we're going to be looking at is kinetic energy. And kinetic energy is a form of energy that an object possesses due to its motion and mass as well. And the formula for it is E equals half mv squared, where m equals mass and v equals velocity. Gravitational potential energy is the other type of energy we were going to be looking at, and it is the stored energy of an object due to its position and mass relative to its gravitational field. And the formula for it will be E equals mgh, where m equals mass, g equals 9.81, acceleration due to gravity, and h equals height. Now we are going to be looking at work, and work is the energy transferred to or from an object when a force is applied over a displacement. And the formula for it is W equals Fs, where W equals work, F equals force, and S equals displacement. Power is the amount of energy or work transferred per unit time. And the formulas for it is P equals E over T, and P equals W over T, where P equals power, E equals energy, T equals time, and W equals work. Efficiency is the amount of energy that can be usefully transferred. Energy equals useful energy or power output over the total energy or power input, and efficiency has no units. So now we are going to be looking at a GCSE example exam style question, where it says the kettle has an efficiency of 91%, and the thermal energy, which is the useful energy of the water, increases by 3.3 times 10 to the power of 5 joules in 200 seconds, and we want to find out the total amount of energy supplied to the kettle. And we need to use the formula over here. So all you need to do is rearrange the formula so you can have the total energy supplied to the device as the subject. So when we do that, we should get the total energy equals useful energy over efficiency. And when we do that, we will get when we do that, we will get 362,637.4 joules, and that's the question done. So now we are going to be going on to the A-level example exam style question, where it states that the water is lifted for a height of 0.45 meters before it leaves the nozzle at an angle of 25 degrees to the vertical. The efficiency of the pump is 76%. Show that the water leaves the nozzle at a speed of 8 meters per second. Mass of water leaving the pump press each second is 3.5 kilograms per second, and the power of the pump is 160 watts. So first we need to find out the useful output of energy power. So using the previous formula, it will be the useful over the total equals the efficiency. So we want to find out the useful, so we just need to multiply the total with the efficiency. So when we do that, we will get 121.6 watts. And so when you do that, and that will equal to the total energy over the time. And in this case, we're assuming everything has taken place in a second. So we're gonna put 1 second as the denominator, and we put the total energy over here. And as it is going upwards and it is moving, we can write the total energy as E equals EGP, which is the gravitational potential energy, plus the kinetic energy. So we can rewrite this as EGP plus EK over 1. And that will equal to 121.6. And if we times both sides by 1, as it is the denominator, it will still stay the same. So if we now sub in all the values that we have in the question into this formula, we should get, so M, which is 3.5, G, which is 9.81, and H, which is 0.45. It says the height is 0.45, so we just need to know the vertical height. And then plus half M, which is 3.5, multiplied by V squared. We're going to work out V. So we just need to do 121.6 take away 3.5 multiplied by 9.81 multiplied by 0.45, as we want to try get the V by itself. So this is the first step in doing so. So when we do that, we get 106.14925 joules. And an important exam note is that always write out your answers fully before you write your before writing the final answer, because the rounding might affect the answer you get at the end. So it's always important to keep the number like full. Only round it at the end to get the answer. That's it. And that's what I've done here. So now we need to do this 106.14925 divided by half multiplied by 3.5, and that will equal to V squared. And so when we do that, we'll get 60.6567 equals V squared, and we square root everything to get V by itself, and when you do that, we'll get 7.8 meters per second, and therefore it is about 8 meters per second, and that's the answer. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.